All right, let's go through this prep review. We'll do a few of these problems here to start with. Okay, if A is at 3, -2, and B as the coordinates 1, 6, what's the change? And triangle is used for change because it's a capital D, and the difference between two things is how you find the change. That's a capital D in Greek. So we want the change in x. Now, if we start here and go to there, it changes by -2. It goes down 2. If we start from here and go to there, it goes up +2. So the change could be either -2 if I'm going from A to B, or it's +2 if I'm going from B to A. So if I'm going to do it from A to B and get -2, then I have to go from -2 to 6, which is +8. If I go from B to A, I'm going from 6 to -2, which is down 8. So either you have this pair for the change in x and change in y, or this pair for the change in x and change in y. Okay. Now I said, determine the length of from A to B. Now several will probably scratch their head and say, I know there's some formula, but I forgot it. Let's draw a picture. A is at 1, 2, 3, -2. And B is at 1, 2, 3, 4, 5, 6. 6 in the y, 1 in the x. So how long is it from here to there? Well, using what we found out in the number 1, if we went -2, we would go up 8. Or if we went from B to A, we'd go +2 and down 8. Either case, we get a triangle that has a side of 8, change in y, and a side of 2, change in x, be it plus or minus, and a right triangle. Pythagorean theorem says a squared plus b squared equals c squared. So the length of AB squared is 2 squared plus 8 squared. And that's what that length is squared, and so we have to take the square root to get the length of just that, from A to B. And that's the exact value. Now you could pull out a calculator and get an approximation for this, 8.2 something, but I wanted the exact value. Midpoint. Well, if we have this picture, the midpoint's right about there, which means it has to be halfway between here and there. This is at 1, this is at 3, so halfway between is at 2. And it has to be halfway between down 2 and up 6, which happens to be up 2. Now, the midpoint formula says average the x's, so that would be 3 plus 1, 4, divided by 2, because there's two numbers, would be 2. And -2 plus 6, which is 4, divided by 2 is also 2. But it's also halfway between 1 and 3, 2. Halfway between -2 and 6, which is also 2. Midpoint is 2, 2. Determine the coordinates of C. if B is the midpoint of A to C. This was A, this is B, and B is halfway between A and C, so C must be up here. And if it's halfway, we go back 2 and up 8 to get to B, the halfway point. We'd have to go back 2 more and up 8 more to get to C. So if we go back 2 more, we'd be at -1. And if we go up 8 more, because this was 8, we have to go up another 8 from a height of 6. 8 plus 6 is 14. That's where C would be. Determine the slope of the line through AB. Well, that slope, if we go from here to here, it's always the rise, the up and down over the run. So it went down 8 for +2. Or we could go from here to here, which is up 8 for -2, plus 8 for -2, which is, in either case, -4 for the slope. Okay. Now you're to write the equation in the y equals mx plus b form. And you've done this one many times, I presume. So y is the slope, which is -4, times the x plus some y-intercept. Now you can use either point to figure out the y-intercept. If we put in the 3 for the x, we're supposed to get -2. So 3 times -4 is -12 plus b is supposed to be -2. So if I add 12 to both sides, I get b equals 10. And I got that using the 3 minus 2. But that's not the equation. The equation relates the y's and x's. Y equals -4x plus the b that we figured out, 10. So I should be able to put different x's in and find the matching y's, or put in different y's and find the matching x. And specifically, since I used the 3, -2 to find the 10, to make sure I've done everything correct, I should be able to put in 1 for x and 6 for y and get a true statement. So if I put in the 6 for the y and the 1 for the x, I should get a true statement. -4 plus times 1 is -4 plus 10 is 6. I get 6 equals 6. That's a true statement. So I've checked it using the other point. Now, if I had chosen to use 1 and 6 to figure out the b, it should have come out to 10 anyway. Then here I would have put in the -2, the 3 and the -2, and got another true statement. Okay. Now there's many different ways to get the equation of a line. This method is just one of them. I'm asking you to be familiar with a couple of other ones. For instance, this one that says the change in y, let's use our first case up here, 8 times x minus the change in x, which is -2, times y is supposed to come out to be a constant. Excuse me. let's just see what the constant has to be. So if I put in 3 and -2 for my x and y, I get 8 times 3, 24, minus a minus is plus, and then times a negative, that makes -4. So -2 times -2 is 4, subtract 4, which is 20. And a minus is plus, so I get the equation 8x plus 2y equals 20. Now, if I'd chosen to use the other ones, the -8 and the 2, I would have had -8x minus, because there, and the change in x was a +2 times the y. And if I'd picked a point to put in, like 3 and -2, I would have gotten -24 plus 4, which is -20. Now this is the same as this, except everything is multiplied by a -1. I can multiply all these by this side by -1 and this side by -1. I get the same equation. If this is a good equation, I should be able to put in also, instead of 3, -2, I could have put in the 1, 6, 1 and 6 in for the x and y, and I should have gotten 20 also. 8 times 1 is 8, 2 times 6 is 12, and I also get 20. So that's the check using the other point. Since I used 3 and -2, I want to write 8 times 1 plus 2 times 6, the 1, 6, the coordinates from the other point, that one that I didn't use, and it should come out to be 20. And if it does, which in this case it does, it checks and makes sure that my equation is working correctly. Now I can also take and solve this or this for y, or this one for y, and I should be able to get back to my other equation. So if I solve this for y by subtracting 8x from both sides, I get 20 minus 8x equals 2y, and then divide everything by 2, and I get 10 minus 4x equals y, and that matches my original equation, showing that this equation or this equation is equal to that original equation there. One other way that they often ask you to do in calculus is the point-slope form, where you're required, if you know the slope and the coordinates of one of the points, the x and y, you should be able to write the equation. y minus the y coordinate from one of the points. So if I choose the first one, I'm going to go choose the 3 minus 2. So y minus the y coordinate, a -2, so that's y plus 2, equals the slope, which we figured out earlier is -4 times x minus the x coordinate. There's the equation of the line. And I used this point. Now I could have used the other point, and I would have had y minus 6 equals -4 times x minus 1, using the 1, 6. This or this is an equivalent to this or this or this or that. Now, if I use the 2 and the 3, the 3 and the -2 to make the equation, here I want you to check using the other one, the 6, 1. So I'd have y plus 2 equals negative 4 times x minus 3. And I'm saying use the 1 for x and 6, and I should get a true statement to check my answer. 6 plus 2 is 8. And 1 minus 3 is negative 2 times negative 4 is plus 8. It checks. Now, if I'd use this one, then I'd want to put in the 3 in for the x and the negative 2 for the y into this equation and check. And if I solve this one for y, let's say subtract 2 from both sides, I'd get y equals negative 4 times x minus 3 minus 2. And then simplify this. Negative 4 times x. Negative 4 times 3 is plus 12 minus 2 is plus 10. And I'm able to change this one back to that form. Or I could change this one by solving for y, adding 6 to both sides and simplifying. I should get the same thing as we did up there. Okay, that's how far we got in class today.